Yeah. So we all are from different colleges. No problem. So in this class, we are discussing about the basis 3 FPGA board and some programs and some introduction of FPGA also. Okay. Yeah. So let's coming to the point. So in this 2 hours workshop, we have learned many things. Okay. So this class is from SSIT is Sense Semiconductors and IT Solutions Private Limited, and I'm introduce myself. So my name is P Tejeshwarrao. I'm the VLSI team lead in this Sense Semiconductors and IT Solutions Private Limited, and I'm working on mainly FPGA prototyping. Okay, so this is my introduction. So coming to your subject, so this is the introduction class of FPGA. So first of all, I'm telling about the what is FPGAs. So FPGAs mean for you all of know about it this full form, field programmable gate array, and this FPGAs is something like it's a kind of board. So we have to dump the code into the FPGA. So it will be showing the output on the hardware verification. It is that a kind of hardware verification. But coming to this FPGAs, there are many kind of FPGAs in the world, like humans. We are very, we are many types of humans, like, so different natures. Same like in the FPGA boards also. There are many FPGA boards like Basis 3, D10 Nano, Spartan 3, and D10 Lite, and Edge Arctic 7, Nexus 4 DDR, and etc. etc. Okay. So majorly we are discussing about the only the basis 3 because of this is the board of because of this board is very easy to understand. Okay. So this is our program agenda, and here I'm showing the how can we dump the code into the FPGA board. I will show that I will show that process also. Okay. So first of all, in these steps, I will show the I mean I will show the output. How can we dump the program? So that is my first process. Okay. This is a very, very interesting one, all of you. So I will explain after I will explain the how can we the background process was happened. Okay. So this is my major thing. So here we are, my first topic, we are discussing about the how can we dump the code into the FPGA board. I mean, so this FPGA board, okay, this is the basis 3. So I will show the how can we dump the code into the FPGA board. Okay. Yeah. So coming to the process, so I will open my Vivader tool and I will share my screen. Okay. I will already share my screen. So I will open my Vivader tool and just this is a demo process. I will show the very small program. How can we dump that? So this is a very, very important process. How can we set the bit stream? How can we see the synthesis and how can we set the pins? Okay. So after we will discuss about the depth of the introduction of FPGA. Okay, how the FPGAs are acting, how many types of FPGA, and what is the main program? Okay, yeah. So just don't worry. Don't worry about that, sir. You are directly moving to the dumping code, but we don't have any idea about an FPGA. I know about it very well. See, some members are don't have any idea about an FPGA. Okay. I know it very well. Yeah. So coming to the process, so I will just introduce this tool. I will just introduce this tool of Xilinx Vivado. See, this is the Vivado 2019.1 version. This is tool was manufactured by the Xilinx company. Recently, it was collaborated with the AMD company also. So this we can call it as AMD Xilinx. Okay, just I'm introducing this software. Okay, and coming to my process here, I'm creating the project. This is the creation. How can we create the project in Vivado? Okay, here you can see this one. This is the create project. So you have to click on this one, create project. So here it will be in a create new Vivado project. Okay, and coming to this one, and coming to, are you understand my language? I mean, are you understood? I mean, see, as you wish. I mean, so first of all, sir, first we are discussing about the FPGAs or shall we move to the dumping process? As you wish, I don't have any problem. Hello, hello. Yeah, hello, hello. Yeah, here nearly 23 members is there. Monica Dattatreya Sharma and Durga Varlaks. Okay, info. Yeah, okay. So that's the major one here. Okay. So first of all, we are discussing about the introduction of FPGA. Okay, yeah, that's the major point. And just give me a minute, I will set up the board. Okay, so now we are discussing about the introduction of FPGA. Okay, yeah. So, I mean, sorry for the delay. That will become a small connection. There is a problem in small connection. So introduction of FPGAs. So introduction of FPGAs. Here you can see the main one, the introduction. So FPGA means we all of know about it very well. The field programmable gate array. Field programmable gate array. So this is the full form I know about very well. But FPGAs are recon reconfigurable. I mean reprogrammable, reprogrammable and reconfiguration. So I know it very well. You have to nothing understand from this sentence. This is the full form. You all have know about it very well. Okay. So this is the full form. FPGAs means field programmable gate array, and FPGAs the reprogrammable reprogrammable means suppose here there is an FPGA board. I'll just draw it myself. So all of you please see this one. This is the FPGA board. Okay, and this is I can connect it with this with my laptop. So this is just I mean don't laugh. So because this is the I mean this is not a funny diagram. Okay, so here we can connect the laptop cable with the board cable. Okay, this is the JTAG communication. This is a JTAG communication. Okay, and I am explaining the FPGAs are reprogrammable and reconfigurable. So what is the meaning of reprogrammable means? First of all, I will write, I can use the divider tool. We all of know about it very well. So I will dump the, first of all, I will dump the AND gate code into the FPGA. So the FPGA will be become a AND gate. It acts like as AND gate because of I am dumped the simple AND gate code into the FPGA. So it acts like as AND gate. After I will dump the half adder. After some time, I will dump the half adder code into the FPGA board. So it will act like as half adder. So after some time, I will dump the full adder and processor, some simple processor. Okay, some simple processor. So after like it acts like is as a full adder and simple processor. One FPGA board acts like as different devices. Here we can dump the different programs, and we can do what we can do here, reprogramming. Did you observe or not? Here we are doing the reprogramming. I mean, here we dump the AND gate code. After we dump the half adder code, full adder code. Here we can do anytimes from the n number of times you can do the reprogrammable on this FPGA board. So that's why we can call it as FPGAs are reprogrammable. Here, first of all, you can dump the AND gate code, it will act like as AND gate. Here you can dump the half adder code, it will act like as half adder. Here you can dump the full adder code, it acts like as full adder. And you can dump the any number of codes, it's act like as that because of it is reprogrammable. And you can dump the any kind of code, it is reconfigurable. Okay, it is called reconfigurable. Okay, and here you can see one thing. My next, all of you understood or not this point? Reprogrammable. See, this is the very point. How many times we have to dump here? It will, the FPGA board will be accepted. That is reprogrammable. Okay, you have, I mean, I will say it in Telugu. మీరు కోడ్ ని ఎన్నిసార్లు అయినా డంప్ చేయండి అమ్మా. సో అన్నిసార్లు ఈ FPGA board యాక్సెప్ట్ చేస్తుంది. That is reprogrammable. మీరు AND gate code dump చేయండి, then you have to use the full adder code and you have to dump the half adder code. It will become like act like as that. Okay, and that's the meaning of that. Yeah. So all of you understood or not? I mean, this point, all of you understood or not? Can you please tell me? Are you understood or not? Yeah. Okay. I will move to the next point. I will move to the next point. So we have discussed about the next point. Yeah. So my next point is FPGAs are faster than CPUs. So CPUs are, means you all of know about it very well, control processing units. In our, I mean, in your college labs and computer labs, you have to see it very well. I mean, beside of the monitor, it will be look like very square. I mean, it will be look like the kind of shape, rectangle shape. So in black color, you all of know about it very well. Okay, so our FPGAs are faster than CPUs. You know, sir, you have a doubt, sir. So you are using the mouse. You're using some normal mouse. Okay, the controlling speed was very too much in your monitor. You all of know about it very well. Because of the CPUs, your CPUs are acting with working with your CPUs are working with microsecond speed, ms, microsecond speed, but our FPGAs are working with the speed of nanoseconds. Here you have to, I mean, you have to move your mouse like that in your touchpad or whatever it may be. So the control signals will be moved to CPU. I will show it in, I will draw and show it in one. So this is our CPU and this is your monitor. Okay, this is the mouse. You have to connect it with CPU and this CPU is connected with like monitor. So this control signal, this you can move the mouse from the left or right side. So this control signal with speed of microseconds, it will be updated into the monitor. The cursor, you have to see the cursor. You can move the mouse. It will be updated in the. It will move to the CPU, and the CPU will be giving to this monitor signals, output signals. The cursor will be moved in microseconds. But we can connected the in the CPU place. We can connected the FPGA. We can connected the one FPGA board between the mouse and monitor. So it acts like as more than speed CPU. I mean, it acts like as faster than CPU. Sir, here we have a small doubt. So why should we connect the CPUs in our monitor? So here we can use the FPGA. It is more than speed. Huh? So why can we using control processing units? I mean, why are we are using the CPUs means because the FPGAs are too much of cost. The FPGAs are cost are too much efficient, like 25,000, 30,000, 45,000. So that's why in many colleges, so they did not give it to you like normal students. Okay, but in our training, we will give that in hands-on session to you. Don't worry. Okay, I mean, confirmly, definitely we will giving the FPGA boards to every student hand. So here we are doing some projects also for the student level and paper publications. Here we are done the many paper publication from the December batch. They are very normal college students like VVIT and RVRGC. So they are very normal college students, but they are done the paper publication with the support of us. We are supporting and we are guiding the people. So they are done the one project and paper publication. That's it. I mean, this is another information. Don't worry. Okay. Yeah. Coming to the subject. So FPGAs are faster than CPUs. So this is, I mean, sir, why the FPGAs are moving with nanoseconds? We can't understand why the FPGAs are moving with nanoseconds because the internal clock. The internal clock is, I will explain this point. I mean, after the session, don't worry. Okay. I mean, after the session means after some time. So coming to my process. So the internal clock speed is 100 megahertz. I mean, the internal clock will be values are depend upon the FPGA boards. For the basis 3 board, the internal clock is 100 megahertz. The internal clock is 100 megahertz. For the Edge Arctic 7 FPGA board, internal clock speed is 50 megahertz. I mean, so this internal clock will be depends upon the FPGA board. Okay. Yeah. So from, I mean, for the every different FPGA board have different internal clock. Like our humans, see, for every human as like here we, I mean, so we have different capability and we have different mindset. Same like as every FPGA board has in different internal clock and different peripherals with from external connections. Okay, yeah. So coming to the next, so all of you understood this one. I mean, FPGAs are faster than CPU. Hello, all are understood or not? Can you please tell me? Yeah, okay, okay, okay. So coming to the next, I mean, coming to the next point. So here, this is the major one. So field programmable gate can be programmed into this. FPGAs are blank and designed. Okay, I will coming to the main point. So you have to observe this one. This is the major one. Don't miss this point, guys. See, these FPGAs are internally consists of mainly 3 blocks, only 3 blocks. I mean, they have internally many blocks, but we are their mainly three main blocks are three. Okay, internally, like I mean, in our human body, they have many organs. But mainly main organs is there. What is the main organs? Heart, brain, something like liver or stomach. I mean, whatever it may be, from lungs or whatever it may be. So we are discussing about the major three. So same like in FPGA internally, they have many internal blocks. But here we are discussing only the majorly three blocks. So that is our CLBs. The first internal block is CLB. CLBs means configuration logic block. Okay. And the second one is what we can call it as, sorry, I forgot. No, I don't forgot. Yeah, input output ports. See, don't see can fear this block. These blocks are very easy to understand. Don't worry, I will explain the everything. Okay, don't worry. These blocks are very easy to understand. I mean, this is a simple process. Okay, input output ports. And the third one is, I mean, input and output ports. And the third one is programmable interconnects. That's it. So these are the major three blocks. I mean, these are the full forms. Don't worry. Okay. Sir, here there are 5 blocks is there, but you are saying these three. Okay, these are the full forms. Okay, these are the main major three. Okay, so these are the major three CLBs. I mean, configuration logic block. These configuration logic block are the main internal block in the FPGA board. I mean, here we are dumped the code into the FPGA. So these CLBs was storing. It will be stored in these CLBs. So that's why we can call it as these CLBs are main internal blocks. I will write it. So these CLBs are main internal block. Main internal block. Okay. And these input output ports, and I will explain programmable interconnects. So I will draw the structure. Just wait a minute. I will draw the FPGA board internal structure. I'll draw the structure. Yeah. So this is our internal FPGA board. Okay. Sir, we have some confusion. So FPGA boards have 7 segment and so something. So this is remain one thing, man. Remain one thing. This is the FPGA board. I mean, I will show the photo also. This is the main central chip. The main central chip. I will just a minute. I will show the FPGA board. So this is our FPGA board. You can see this one. This is our FPGA board. Okay. We do not call this overall. We do not call this overall. Just yeah, sorry, Amma, sorry for the disturbance. Okay, so we don't call this overall this FPGA board. We do not call it as like this is the FPGA board. You can see this one, this central chip. All of you observe this one. I will show the photo also. Don't worry. I will show the pic. Don't worry. Okay, I'll show the pic. I mean, I will open the website FPGA. So all of you, my screen is visible to you all. All of you. See, don't call this overall. Don't call this overall this FPGA. This central chip. This central chip is like a heart or heart, a brain of this FPGA. Okay. This central chip. This central chip is the main we can call it as FPGA IC. Okay, so that this is the internal structure of FPGA IC. This is the FPGA IC, not overall this board. This is the that main central chip internal diagram. Okay, architecture. Sir, we can't understand anything like overall. There is many peripherals there. I will explain. Don't worry. I will explain this each and every point. So you are saying like that. So you are saying something like so. This is the main block. See, this is the main chip and the main block. I mean, simply don't call this overall. We can call it. Don't we call this overall? We can call it as FPGA. This is the FPGA. This central chip we can call it as FPGA. Because of this central chip will be controlling these 7 segments, switches, LEDs, pen drive connection, VGA, etc., etc. Okay, don't worry. I will re-explain it. We are coming to the FPGA. I will re-explain it. But I am drawing this central architecture, this internal architecture. Okay, not overall this architecture. Yeah. So coming to this one. So this here I am drawing the FPGA at central architecture. Yeah. So here there are internally in the CLBs. I mean, how many blocks we are there? How many main blocks we are there? CLBs, input outputs, programmable interconnects. Okay, first of all, I will draw that. First of all, I will draw the main internal structure. Okay. First of all, I will draw the main. It will be to take a 1 minute. Wait a minute. I will draw this one. Yeah. So here you can see the one thing. These CLBs, are internally consist the lookup table, LUT, lookup table. Okay. So this internally, I mean, this CLB internally consists the lookup table. Sir, why are this lookup table? I mean, we cannot, we don't know about this word. What is this lookup tables means? Example, I will show the one demo program. I will show the one demo program. How can they internally act? Okay. Suppose we have an AND gate. Suppose we have an AND gate, man. What are the inputs? Just like we have to take it like student level A, B. Output is out. Output is out. So what are the truth table for this? What are the results of this AND gate? I will draw this one, and I will draw this internal architecture. So this is the LUT. See this one. This is the LUT. This LUT will be internally consist the AND gate values. I mean, this is the demo program. Okay. These LUTs will be consist the these internal values, because we can dump the code into the FPGA. These values will be moved into the lookup tables. Okay. And here we can give the 0, 0. It will be select the 0 and giving to the output 0. Sir, we are have some confusion. So can you explain me the very detailedly? I mean, I know very well. Okay, this is will be become a confusion to you. Okay, I'm coming to the explain everything. Okay, so yeah, please. Anyone have any doubts? Anyone have any doubts? Yeah, please, Ajay Kumar. Hello. Anyone have any doubts? Divakar Reddy, Durga Varalakshmi, Jogesh, and Subramanyam, Kavya, Kush Patel, Polkar Mustafa, Harshita. Anyone? Anyone have any doubts? So please tell me. Vamsi, Swati, Shrinu, Teja Varma. Okay, no one have anyone have no doubts? I mean, can you please tell me? I mean, I did not understand anything here. What happened? Hello? Are you listening this class or not? Hello? Okay, I will explain about the LUT. Okay, okay, okay. See, simple ma. See, I mean, here we can dump the, I mean, here we can dump the AND gate code. AND gate code, these into the FPGA board. So these AND gate values, we know about the result values. These AND gate values will be stored into this LUT. They have internally select these LUTs and it will be stored like this. Okay. And I mean, so coming to this point, so sir, where is the input output blocks and remaining things? We have to doubt something like that. So you have to see this one. You have to see this one. So this is the input output ports. This is the input output ports. Sir, what are the input output ports? We can't understand anything like here. What are that input output ports? Means this A and this B and this out. We can call it as input output ports. Suppose we have to select like A is the, I mean, we have to connect some pin number, pin configuration number W5, and this is the W6 and this is the W7. As I like it's input and output ports. So here this W5 pin is there. So this is the A. And the W6 pin is there. This is the B. And the W7 pin is there. This is the output pin. Okay, sir, everything is good. I mean, here some respect. This that will be the place. Sir, why should not you connect the B here, and why should we not connect the C here? That will be depends upon the pin number. That will be depends upon the pin number. Okay, the positions of this like B and A, and this is the W5 position, and this is the W6 pin position, and this is the W7 pin position. Okay, that positions of input output depends upon the FPGA. Okay, and coming to the point, so here we can connect the input output ports. So the LUT, this is the internal structure. This is the internal structure of LUT. I will explain. Will explain about the LUT. Don't worry. Okay. After this process, I will explain about the detail about the LUT. Okay. Yeah. So coming to this point, okay, input output ports, you have to understand. Okay, these AB and out our normal input output ports. These we can call it as input output ports. What are the programmable interconnects? What are the programmable interconnects? This communication between these input output ports and LUT. Connections, communication wires, connection lines. These lines we can call it as programmable interconnects. Okay, so I will explain. Please, all of you, please listen this process. Suppose I will given the 0, 0 here. I mean, after dumping the program, after dumping the AND gate program, I mean, I will write the AND gate Verilog code here. I will dump the code into the FPGA board. After I will give the some switches. I will use the switches here. I will use the switches here. So this is the LED. This is the LED. So I will give the 0 0. Okay, I will take the another value. I will take the 1 1. I will take the 1 1. The 1 1, the 1 is come here. The 1 is come here. So it will be, I mean, so this is the maximum maximization. This is the maximum. So 1 1. So the 1 1 will become here. So the 1 will be selected into the LUT. The 1 will be selected into the LUT. So the LUT will be, the 1 will be out. So the output will be 1. The LED will be blinked. This is the, how can we, these like, they can show the output into the FPGA board. Are you understood or not? I know some confusion is there. So there is a little bit confusion is there. So I mean, so I will repeat this process. Okay. Suppose I have put the 0 1. 0 1. So 0 will be moved to here and the 1 will move to here. So what is the 0 1? What are the value for the 0 1? Can anyone tell me? This one, 0. So 0 is the output. So 0 is the out. The LED will be off. I mean, the switch will be down. The 0 means switch will be down. The 1 means switch will be up. That's the meaning. That's, you all have noted the switch connections very well. And this is the, so this is the identifying this like kind of output in LUT. So here you can come into this LUT main process. Zero 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 one. Sir, we have a small doubt, sir. How can the values are coming to this LUTs? How can they know these LUTs? How can they came from this values into the LUTs into the FPGA board? అంటే ఈ ఇందులోకి వాల్యూస్ అనేవి ఈ ఎండ్ గేట్ వాల్యూస్ అనేవి ఎలా వస్తాయి సార్ మనం కోడ్ డంప్ చేస్తే అండ్ యూ హ్యావ్ స్మాల్ డౌట్ ఇన్ దిస్ ఇంటర్నల్ ఇన్ యువర్ మైండ్. See here we are done the simulation. We have done the simulations in the FPGA board. Sorry, in our laptop. I mean in our software. So that values, that simulation output values we can give into the synthesis. Okay, and these synthesis, what you know the meaning of synthesis? This is the representation of LUTs. You can observe in the Vivader tool. This is the LUT representation of the circuit. This is the LUT representation. So we can represent like this. You can move to like, you can write the AND gate code. I will show this. This is the synthesis schematic. This is the synthesis schematic for the LUTs. So this is, that is the meaning of like, it will be store the values 0 0 0 1. Okay, and so you know this one block, one value will be stored here. We can call it as SRAM. We can call it as SRAM because of the SRAM will be stored into the 0 or 1, anything only 1 bit. So that is the SRAM. Okay, so this is the total information about the LUTs. I mean, and I have a small doubt, ma. I mean, shall I ask one question to you? Hello, shall I ask one question to you? Hello, shall I ask one question to you? Are you ready? So here, I mean, this is a very simple question. Don't worry. This is a very simple question. So here you can see this one. This is the LUT2. Why we can call it as LUT2? Can anyone tell me? Open, I mean, on your mic. I didn't see the comments. Okay, because of I'm in another tab. So open your mic and tell me the why we can call it as LUT2. This AND gate code. Come on, tell me. So you did not listen to the class? Why we can call it as LUT2? So why we wait? Why do not we can call it as LUT5, LUT6, LUT7, LUT8? Why we can call it as LUT2? Okay, no problem. I mean, so you have to put the comments. Don't worry. So all of some called as fears. So all of you, please send your comments. Answer in comments, please. Why we can call it as LUT2 for the AND gate? Why do not we call it as, why don't we call like that LUT5, LUT6? Shall I explain? Hello? Shall I explain, man? Shall I say the answer? Because they have two inputs only. That's it. Because of the, see this one, this LUT2 means there are only two inputs. So that's why we can call it as LUT. Suppose we have a full adder values. I mean, we all of know about it. This is the sum and carry and different values is there, something. They have how many inputs? A, B, C, sum and carry. So LUT3. LUT3. Because of they have full adder has three inputs. So that's why we can call it as LUT3. That's it. This is a very easy to understand. So, okay. So I will ask the another question. Anyone have any intelligence? So you have to say the answer. Okay. So here you can see this one. There are different LUTs in these CLBs. Suppose they in this CLB they have LUT3, 6. In this CLB they have LUT9. I mean, for the based upon outputs. So in this LUT they have LUT2, and I mean here the LUT2 is there. I mean, I'm saying just like it's like example. So it's like as a normal as is architecture. Just I will say in the example. So this here they have LUT6, LUT7 or LUT8. Okay. So here in our synthesis will be generated the LUT2. Synthesis process will be generated the LUT2. So how can we find this LUT2 one in our FPGA board? How can they do the exact connection to this CLB? Did you understand my question? So why don't they choose the LUT6? Why don't they confuse? Correctly, they are matching the inputs and they're connecting, they're choosing the LUT2. Suppose, I mean, I will ask the another question. Suppose, okay, sir, because of the inputs is matching, so that's why they can connect to this LUT2. Okay, I will see, I will show like this one. Suppose I will take the half adder, sum and carry. So this is the LUT2. Why don't this come to this one? Why did not this choose this one? They have they have two inputs, but they have two outputs. Why don't they choose this one? Are you understanding my question or not? Please tell me. Are you understanding my question? Hello? Are you understanding my question, ma? Or not? Can you please tell me anyone? Hello? Are you understanding my question, Madhavi? I mean, normal, can you, all of you? Yeah. How? I mean, okay, I'll repeat my question. See, ma, we have the LUT2 lookup, LUT2, two inputs, one output. This is our synthesis will be generate this LUT in our Vivado tool. Okay. How can they exactly find this LUT in this CLB? How can they find? Why didn't we find? Why didn't we? Why did not they connected into this like half adder LUT? They have all the two inputs. This is the half adder. Why they did not confuse? They how can they exactly connect it to this LUT2 and one output? Tell me. How can they exactly connect it? They can choose the two input and one output. Why didn't they choose the half adder like LUT2? This is there are like many LUTs are there. CMI in our FPGA board, they have thousands of CLBs, thousands of configuration logic blocks. They have lakhs of lookup tables. How can they find these exact LUT? How? How is it possible? How they can find the exact LUT like two input, one output? How can they find exact LUT in the CLBs? Because of that is the process we can call it as uh, routing. Routing. Okay, routing process. The routing step will be choose the LUTs and the path of the LUT. Okay, give me a minute. This is another point. Uh, I'll ask another question. Okay. Okay, okay. We'll move to the next process. Okay, don't worry. So this is the all information. This is the all theoretical information about the FPGA. Okay, so this is the all theoretical. I mean, so see, this is the small information. I think did not understand anything here. I mean, from the last step of synthesis, like entities, something something. You didn't. I mean, some members are did not understand like in from the depth one. See, because of this is the demo class, I did not explain anything openly. I mean, much and more because of we have one more time, 1 hour extra. I mean, 1 hour time is remaining. So I did not explain much and more in depth process. So you have to understand that one. Okay, if you have any interest, then come to some intent. That is the end of the process. So we are doing some projects to the with the students' hands. So we are doing the publications. Some one student will be done the 2 publications with the UGC care indexing. And if we have more money, then you have to do the scoopers and competitions also. Here we are encouraging some more of competition. Recently, the VDET 2025 competition is there. Anyone know about this one? This is the May 15th is the target. Hello. Anyone interested? Anyone have any good ideas? Anyone have any project ready ideas? Then you can submit your idea. I mean, you can submit your document into that VDET 2025 competition. Okay, so we are encouraging the competitions, paper publications to the students, and they have from the different colleges throughout India. Okay, so coming to the next process here, I can explain about the basis 3. Here, I can explain the basis 3. All of you, shall we move to the basis 3? Or anyone have any doubts on this FPGA introduction theory? Anyone have any doubts? So please ask me in comments. Don't worry, don't on the mic. I mean, don't fear. So anyone have any doubts in the theory? I will re-explain within simple points. I will re-explain in simple way. Okay, please. Otherwise, we will move to the basis 3. I will explain the internal blocks. Hello. Hello. Shruti, Swati, I mean, Jagadishwar Shetty, Durga Varalakshmi Anisetti, Kavya, Kush Patel, Ashita, Madhava, Mohammed. Come on, please interact with me. Don't worry. See, don't this class is like don't fear. The fear is the main weapon. Main weapon to decrease yourself. Yeah, configurable means I mean reprogrammable means how many times we can dumping like how many times we can dump the FPGA board. I mean how many times we can dump the programming. Okay, I will show this one. I mean, see, reprogramming means uh, reprogramming means so they can how many times we have to dump here. They can dump into the FPGA board. How many times we are doing the programming, it will be accepted the reprogramming also. AND gate, half adder, full adder. How many times we dump the code, it will be accepted. That is the reprogramming. And reconfiguring means here, I mean, some FPGAs are non-volatile. FPGAs are non-volatile. Reconfigurables. Our FPGAs are non-volatile. I mean, can I show something? Like after dumping, you can suppose here we can dump the AND gate code into the FPGA board. So it acts like as AND gate. We all of know about it. Here you can remove this cable. You can remove this cable once in the middle of the process. I mean, after dumping the code, middle of the process, you can remove this. I mean, you can remove this cable. The code, the data, the code will be deleted. The code will be deleted. So that is the meaning of non-volatile. And coming to the read configurable, how many such kind of internal blocks it will be accepted? How many times? I mean, there is not, there are both are similar things, but they have different between the code types. Code types, any kind of syntax of code that will be reconfigurable into the FPGA board. Okay, that's it. So anyone have any other doubts? Anyone have any other doubts? So please ask me. Hello? Anyone have any other doubts? See, CPU and I mean, see, that is related to embedded mark. See, I mean, VHDL, I mean, can I say something, Mohammed? I mean, can I say something? Don't feel, I mean, I can say my open point. See, the VHDL is the olden language because of the many more library installations is there. So there we have to update the VHDL from the Verilog. Because of these programming, this Verilog programming is extension to the system Verilog for the design verification and RTL designing, RTL engineering also. So that's why. So the VHDL is the olden, some in 2010s and 2011s, 2012. I mean, that is famous, but nowadays it will be, it will be some members are using still, but for the industry, it will be the VHDL is not accepted. I'm showing my open point. So anything you have to say, will take in the point like nothing. We are doing the Verilog. We are doing the maximum. We are doing the programming in Verilog because of why? Because of the industry will accept the system Verilog in RTL and design verification. So that Verilog, you can understand the Verilog, the system Verilog syntax is very easy to understand for the Verilog members, not the VHDL members. Okay. I mean, what component instantiation means what? What is the meaning of component instantiation? And sir, I got this, but I am unable to understand, like we need to, since we have CPUs and GPUs, other micro. See, this is not related to microprocessor and microcontrollers. This is the ICs. This is the ICs. See, this overall VLSI is related to chip manufacturing and chip fabrication. Okay, this is not any kind of related to PCBs. Okay, that is related. That's microprocessor and microcontrollers are related to embedded. Okay, and this is not related any kind of CPUs, I mean microcontrollers and microprocessors. See, these FPGAs are, we can call it as manufacturing. This VLSI field is overall for chip fabrication. That's it. Okay, and anyone have any other doubts? Shall we move to the FPGA board? Hello, hello, hello. Is there any connection? Hello? Yeah, yeah. See, I mean, can anyone please respond? Because of I will remind myself. There is a loose connection. I mean, there is internally something a problem. Okay. Shall we move to the FPGA, basis 3 FPGA board?
Yes, sir.
Yeah, please.
Okay, sir.
I mean, I mean, answer some mic, please. చెప్పండి పర్లేదు. Where we have used the FPGA boards, sir. Yeah, here we are using the FPGA boards. We can connect the through cable with your laptops and your systems. That's it. We are connecting. I mean, for the student level, you can use the FPGA boards. You can connect it like this with laptop. I will show. I mean, I will show the demo also. Don't worry. For the last 10 minutes, I will show the demo FPGA board. How can we connect this laptop to the FPGA board? Okay. Here, after the basis 3 components explanation, I will move to the how can we dump the code into the FPGA board. That's it. Okay. Don't worry. We'll move to that. And is there any other doubts? Sir, FPGA, how to work in encoder and decoder? Yeah, we can dump the encoder and decoding program into the FPGA board. So it will be very easy to explore this encoder and decoder. Yeah, you can use the, I mean, CMR, any kind of application, any kind of processor, you can write the Verilog code, then you can dump then you can dump into the FPGA board. It acts like a CPU or encoder and decoder. That's it. You can write the any kind of Verilog code. Suppose you can write the encoder, these FPGA board will be become a encoder. Here you can dump the CPU. It will the FPGA is acts like a CPU. Because if it is reprogrammable, it is accepted the any kind of program. Okay, it is accepted the any kind of program. This is the one basic student level, basis 3. I mean, some students of all of know about very well. This is the basic level student board, and we have using the some advanced levels also. We are using some advanced levels also. Okay, so we are offering the summer internships, and many students are know about it very well. Okay, in summer internships, you can learn the anything. From summer internships, we are doing some paper publications, also projects. The projects are very important to your student life career. Here you are doing the higher education, then you any lecturer you can say you okay do some paper publications. The lecturer, I mean in our BTech, some lecturers are don't know about it very well. You can move to the NITs or IITs. The lecturers was mandatory to say do some paper publications. To the students, do some paper publications is very important. The lectures are mandatory to say in NITs and IITs. In triple also, some triple also be like that. Some normal colleges, it is, I think it is not mandatory rule. I don't know about the normal colleges. Some colleges are interested, some colleges are not interested. That's it. Yeah. So coming to the basis 3. Yeah, I mean, see Ajay Kumar, you can dump the AND gate code into the FPGA board. That is the hardware verification. Okay, all will be worked. I mean, all is good. Then it will be moved to the chip fabrication. After it will move to the IC fabrication. So the IC will be generated. The IC will be generated. After this hardware verification, that dumping program will be moved to the chip fabrication. I will explain it. I will explain this one. So thank good doubt. So here we are done this is for hardware verification. FPGAs are mainly for hardware verification, for programming hardware verification. Yeah, hardware verification. Suppose we are done the AND gate code. AND gate code. So here in this AND gate, all are very good. Okay, we can on these two switches into one, the LED will be blinking. Okay, so we can give the 0 1 condition, the LED will be off. Okay, everything is good. This AND gate code we can move into further using some tools. We can move to further chip fabrication. Chip fabrication, you know about it very well. 7408 7408 IC. You all of anyone know about this 740 IC 08 IC? How can they manufacturing? How can they directly they can manufacturing? No, they can you write the Verilog code and dump the code into the FPGA board. Then they will move to the fabrication of this code. They are designed like that. They're using to design like that. This like they can directly move to the fabrication. After dumping the code and they will move to like fabrication. After fabrication, they are testing the chips and they are allowed into the market. So some lab technicians are moved to the market and they can purchase the 7408 ICs. All of you know about in 740 I mean 7400 ICs number, AND gate IC number, OR gate IC number. Okay, yeah, and okay. Anyone have any doubts? Hello. Anyone have any doubts, ma? Hello. Gotta keep quiet. Why else keep? I mean, is this library? This no, see, ma, this is not any kind of library. Is there? So all of you, please open your mics and ask some questions. See, interaction is very important. Yeah, sir, is there any offline platform to check the code and simulations purchase PG just for simulating checking the code? See Ajay Kumar, if you have any interested, then come to summer. We can offer the in summer for hybrid mode. See, these kind of this kind of classes will be happening online, but we are allowing the members into offline also. But we can give the FPGA boards into your own hands. So here you can do some programming. That's it. But you can purchasing an FPGA boards, that is not a simple cost. The cost is nearly, this the basis three cost. You know about this basis three cost 25,000. So that's why in your colleges some members are did not give into the FPGA boards in your own hands. That's it. I mean, yeah, this you can check it like yeah here you can contact Surya. That's it. You can contact Surya. That is I mean you can contact Surya. That will be easy for this. My further details. I mean my contact or summer contact. Just some clarification. You're asking my contact or summer or any kind of company contact. See, my contact, I am not lifted my phone anywhere. I'm do some sleeping. That's it. Because this is the weekend. So that's why I'm free now. In Saturday, sorry, in Monday to Friday, I'm very busy with my schedule. I'm very busy with my projects also. So this is the Sunday. I'm very free to student interaction. This is my mind refreshing. That's it. Yeah, coming to the basis board. Okay. Yeah. I will use the board also. So this is the central chip. This is the central chip. What is you can see the name. Anyone observed here? What is the right here? What are the right here? Xilinx Arctic 7 XC7A 35T. I mean, you did not observe these words. I will write here. I will write into the board. Coming to the basis 3. Basis 3 FPGA board. Don't worry, ma. I will share these notes. Don't worry. I will share these notes to you. Share to the Surya, and you have to collect from the Surya. Okay. I will share these notes. Yeah. So first of all, XC7A 35T CPG 256.1. This is the basis 3 board. Basis 3 FPGA board. Sir, we can't understand anything like what is this kind of number here? What is this number? So simply we all know about it. This basis, we know basis 3 FPGA board is name. So what is this number? Means this is the part number. So what is this part number? We can't understand anything like that. Suppose in your colleges, you have some name. Suppose like, okay, I will share Swati. Yeah. Suppose in your colleges, Swati, suppose in your college, you have represented with your name or ID number. Example, you have to take in. So in your college, you have to represent it with your name or ID, any kind of ID number. Please tell me anyone. They can call your name or ID number. Can anyone tell me? Name? Sure. ID number. I mean, many colleges are giving to the ID number to the students. Why? They can represent, they can easy to identify. Understood, man? They can easy to identify. That's it. They can easy to identify. So that's why here also this is the FPGA's ID number. So the Vivario tool or any kind of tool, they can easily identify the FPGA board number. FPGA board. Easy to identify. See, suppose, you all of know about it. Suppose I will show my ID number. I will write example my ID number. Ma. So N1800563. I'm from the Triple news video. I'm from the Triple news video. Example, man. Don't worry. Okay, don't take any partiality. Okay. Yeah. So I'm from the Triple news video. Nujvidu. So this Nujvidu is represents this n. This 18 is 0 is represent my year, my joining year. This NA1 my joining year. I mean, this is the example ID number. This is not my original ID number. So all of you don't look at it to my okay. This is a fake ID number. So I mean, I am very clever. So I didn't give my ID number to you. Okay, this is the fake ID number. Yeah. So this is this ID number with represented my, I mean, serial number. Just a minute. There is no, yeah. So this is 563 is my student number. I mean, just normal count of students. That's it. So coming to this one, if this FPGA board, XC7A. Yeah. So this XC7A Xilinx. So this board is from the Xilinx. Understood or not? This board is from this XC7A means this XC. Majorly we have to discuss about this XC. This is from the Xilinx. And this 7A means what? Arctic 7. Arctic 7. I will show it one. I will show this one. So see this one, Arctic 7, Xilinx Arctic 7. The internally consists of FPGA board. So that means XC7A. That's the meaning of this one. They can easily recognize by the number. This 35 is related. This 35 CPG. This 35 CPG is related to the family. Arctic's family. Arctic's family part number. And this is the board number. This is the board identification number, like my student count. So that's like it. So this is like that. Okay, easy to identify. This is the main ID number. So all of you understand what I'm saying. All of you understood what I'm saying. I think all of you understand or not. Can you please tell me? Hello. Hello. Yeah. All of you understood or not? Can you please? Can you please anyone tell me? All of you understood or not?
Yes, sir.
Yeah. Yeah. I mean, Durga Varalakshmi, are you understood? I mean, because of we can identify, we can give the ID number, part number only in our Vivada software. Don't call with we do not call with the name in Vivada software. Okay, we can call with the part number only. Okay, so they have internally they have many blocks. I can explain the many blocks. Okay, so first of all, I will explain this one. I will explain this part, the power consumption. This is the very important code now. In any kind of class, any kind of NPTEL class, any kind of YouTube class, you did not found this one. You did not found this topic. Explanation of FPGA, any kind of FPGA board. Definitely, you can find any kind of NPTEL course. You can find any kind of YouTube course. You did not find this kind of class. Trust me. First, I'm trusting the simple. Please, anyone have any doubts? One number is hand raise. Anyone have hand raise? Okay. Yeah, coming to the basis 3. So this is the cable connection code, ma. How to see this one? Cable connection. Here we are connecting the cable. I will explain it to you. I mean, here we are connecting the laptop with C cable, with C-type cable to the J tag. So we can call it as that J tag is this one, programming. So this is the switch for on and off programming. Okay, this is the switch for on and off programming. Sir, we are confusing. What is this one? What is this one? Their USB is there, external connections is there. We can't understand anything. What is the meaning of this one? We can't understand anything. So this is the switch, ma. Simple on and off. Wait a minute. So simply, you know about this switch on and off. Just we can put the output. It will be on, and it will be off. That is very easy to understand. You. I will explain the each and every block. So please write these points. I mean, it is very easy to important. This is the JTAG programming with cables. Okay. And this is the switch. And coming to this power consumption, I will write this one. I will write this one. Here, how many pins is there? 3 pins. I mean, 3 pins more. The jumper will be connected to these 2 pins only. This is the external connection. This is the USB. I mean, I will show the diagram, don't worry. See this one? These 2 pins is for external connections. See this one? These 2 pins is connected to USB. I will explain. This is the, I mean, don't take like a big one. This is a very easy to understand. Can I explain? All of you. See, you can select these 2 jumper wires. You can select these 2 jumper wires. It allows the code. Sorry, it allows the power. It allows the power from our laptop. That is the meaning. This USB meaning means it allows the power from this cable. Here we are connecting the cable, no? I mean, here we can choose the USBs, so they can allow the power in with from our laptop. They can allow the power in our laptop. Here you can choose these external. Here you can choose this up to external. Suppose we can select the jumper wire. We can put the jumper. All of you please show this one. Here we can put the jumper. They did not allow that. I will show that one. Oh, okay. After I will show this one. Okay, don't worry. Yeah, it will be not allowed. It will be not allow the power. Okay, that's it. I mean, sir, how can the external means? What is the meaning of external? Yeah. So here we can connect it to the jumper with these two pins. I'm saying this one. Here you can connect this jumper with these 2 pins. The JTAG will be not allow the power. I will write these points. It allows the power. So we can choose the external. It will be not allow the power. Not allow the power. It will be not allowed the power by JTAG cable. By JTAG cable. So here we can connect the UCB. I mean, it will allow the using JTAG cable. That JTAG cable means this one. This is the JTAG cable. That's it. Okay, don't worry. JTAG cable means it's a wire. You can connect this this wire. Okay. Sir, how can we allow this is the external connection. You can see this one. All of you, my cursor is visible to you. Hello? Hello? My cursor is visible to you or not? Hello? Hello? See, can anyone please tell me? I mean, my cursor is not visible. What? My cursor is not visible. So, yeah, okay. So, is it visible or not? My cursor. Tell me. Please, can anyone on the mic and tell me now? Only one person. Only the confirmed person. My cursor is visible
No,
to you?
sir. No, sir.
No, sir.
Still no. Here? Now?
No, sir.
Oh God. Okay, I will use this one. Here, my cursor is visible. Now, my cursor is visible to you?
Yes, sir. Yes, sir.
Okay. So this, I mean, this is I can explain about this JTAG ma. This is the connection. Okay, this connection. Here we can use this JTAG from this connection. This is the power and on and off switch. And this is, I am telling about this jumper. Okay, this jumper, you can connect these two pins. I mean, I will explain. This is the allow the power into the JTAG. Here you can select this external. It will be allow the power from the external side. It is the, we can like this 5 voltage from the external battery. You can connect the battery to these wires, so it will be allowed like this. Okay, that's it. This is the very simple point. Here you can connect the this jumper wire to the down. I mean, I will explain here. Here you can connect this jumper to this down wires. You can select this two down. It will be allows the power from the JTAG cable. Okay, you can connect this upper two. It will be allow the power from this external connection. Okay, sir, why can we choose this external connection? We can't understand anything. Why can we choose this external connection here? Please see this one. In this here, the JTAG cable is there and the USB port is there. The pen drive, the USB port is also there. Are you understood or not? Here the USB port is also there. Here another jumper is also there. Another jumper. They have 4-pin jumper is there. I will explain about this one. Wait a minute. I will connect this one. Yeah. So coming to this one. See, Amma, this is the very depth subject. I think you need to understand it is a very mandatory. So here we have 4-pin wires. Don't worry, I will explain. I will write it. This is the QSP mode. And the third one is JTAG mode. And this is one for the USB. Sir, why sir here there is a 4 pins, but here there is a 2, but there is a jumper. See, you can connect this one. It is for QSPI. Here you can choose the middle one with jumper. Here they can allow the JTAG. Here you can choose the, I mean, I will put it in the box. Okay, I will wait a minute. Here we can choose the last two with jumper. So it is for USB. This allows the code from the USB. You can connect the pen drive and you can allow the code. That is another possible. See, on a laptop, you can dump with laptop and you can use the pen drive. It is also useful for that. I mean, here we can FPGA board. Here you can connect one pen drive. Here you can connect one pen drive. So here you all see here there is another process you can dump the code with the central chip. Okay. Here this is also another, I mean, so how can they allow the pen drive? Here you can connect this USB connection. To this you can connect the jumper to this last one. I mean, you can connect this jumper to the last two, so it will be allow this pen drive. Otherwise, you can choose the any kind of QSPI or JTAG. So it will be allows the code. I mean, this is for code, not for power. This is for code allowing. If the code is in pen drive, you can select this to, I mean, this is the 2 wires. You can see these 2 wires. I mean, you can select this 3-4 wires. It will be allow the pen drive, but you can connect the 1-2 or 2-3. It will be allows the laptop code. I mean, so it will be allows the laptop code. It will be allows the laptop code like this. This is for code, not for the power. Power is done. Sir, we have some doubts, sir. Here we can connect in this pen drive. How the power? Where the power it came from? Here we can do the external connection. from using these jumper wires for the 2 up. I think, shall I re-explain this process or not? Can anyone tell me, shall I re-explain? Hello?
Yes, sir. Re-explain, sir.
Anyone understand? I mean, give me a minute. Anyone understand? I know this is the process is this is the first members. I mean, I know this is the first time to listen this kind of. Okay. I will one more explain. Don't worry. Because of this is the first time to you have to understand this kind of concepts, this kind of hardware. CM of our BTech students, this is the, I mean, from our students, I mean, comparing with our intern students, they are easy to explore that any kind of FPGA board. I mean, say the real things only. Okay, I will re-explain. Coming to this one, see, I mean, I will show the board also. So this is the JTAG cable. I mean, on our FPGA board. This is our FPGA board. This is our JTAG cable. This is the on and off switch. This is the on and off switch. Here 3 pins is there. The 3 pins is there. Here you can connect the jumper for these 2. This is for allowing the power. Allowing the power. I mean, I can write from the laptop. I mean, a laptop or from our computer. Whatever it may be, our computer. You can connect this. I mean, from the down 2 pins. I mean, the 1, 2, the 2, 3 pins, it will be allowed the power. It will allow the power from the laptop. Okay, here you can select the, I mean, here you can select the upside 2 pins with jumper. With jumper is there. So it will be allows the power from the external connections. The 5 voltage is there and ground is there. So you can connect one battery. So you can connect this 5 voltage and ground. So it will be power allow from this one. For why? For why? Because here for the code dumping, you can connect the pen drive is there. Here there is a USB. Here you can use the pen drive. I mean, pen drive is this is the pen drive. Here you can use the pen drive. There is any, it will be providing any kind power to the FPGA board. The pen drive will be provide the source of data. I mean code. Here it will be provide any kind of power. Pen drive provides it will be provide. Is it provided the power to my FPGA board? The laptop will be provided because of the one cable is connected. It will be allows the code and power both. But the pen drive is only is it provided the power? Tell me, ma. Anyone? Is it provided the power? The laptop? No, sorry, the pen drive. Is it provided the power? No. The pen drive will be provided only the code. There will be, I mean, we all know about it very well that we can dump the code file. I mean, one file is there, we can easily dump the code file. So for the pen drive purpose, we can use these external connections. Are you understood? So that's why we can use these external connections. We do not connect the laptop. How can we allow this pen drive code? We cannot directly. So here there is a 4 pins. There is a 4 jumper pins is there. You can choose these 3-4 jumper wires. You can choose last 2 This is for the USB. I mean, this pen drive. Simply for pen drive. You can choose the 1, 2. I mean, you can choose the 1, 2 or 2, 3. This is for JTAG. This is for easily allow the JTAG code. I mean, this JTAG. Okay, this is the JTAG mark. I mean, I'm saying the JTAG. This is the means JTAG. The QSPI is also available. So you can connect the 2, 1, 2 means jumper is there, or jumper is to 2, 3. It is allowing the JTAG cable, but you can connect the 3, 4. It is allowing the code from the pen drive. Okay, I'll show the hardware board. Here, this is the pen pen drive. This is the 4-pin jumper. Here you can, there is writing in the down QSPI. I will zoom it. I'll zoom it this one. Here you can observe this pen drive. You can come to the pen drive. It is the 4 jumper wires. I mean, my cursor is visible to you. My cursor is visible to you. This is the pen drive. Hello? Can anyone open the mic, please?
Yes, sir.
Yeah. Thank you. So this is the pen drive connection. This is the 4-pin. So here you can connect these 2 pins. It will be allow the code from the pen drive. Otherwise what happened? It will be allow the code from. It will be allow the code from this JTAG. So is it very easy to understand? But keep it in your mind. It will be safe. Okay. See, I will provide the notes, but you have to store it in your mind. Okay. Because of, sir, why the power is very, very important to this FPGA board? Because the FPGA board is non-volatile. We can remove the power. The code will be automatically deleted. That's it. Okay. Yeah. So this is the about these jumper wires. This is a very, very depth subject, man. This is a very, very depth subject. Okay. I mean, in any kind of YouTube classes, they cannot discuss about this one. Okay. The central chip is over, and the pen drive and these jumpers and power, this consumption is also over. And coming to this PMODs, you know, see this one black color PMODs. I mean, this black color one. My cursor is visible to you. These black colors. These are, we can call it as PMODs. I can explain this one. See here, these are, we can allocate as 4 PMODs is there for in our FPGA board. There are 4 PMODs. As usual for this, there is the 4 PMODs. This is for XDC and this is for XDC. I mean, no. I will explain. Don't worry, ma. Don't confuse. I will explain this about this PMODs. Don't worry. See, this is the connection of PMODs like this. There is a holes of this PMODs. Okay. There is a holes of this PMODs. Sir, what is this PMODs? We can't understand anything like this. This is simple. This is very simple. This is XADC. I will explain. This is the X1. I mean, this is the J1. This is the J2, and this is the J3 for PMODs. Okay. So, can anyone tell me? Hello. Can anyone in this meet? Can you help me? Yeah, Ajay Kumar. Hello, Ajay Kumar, are you there? Yeah, please on your mic. Only one time. Okay, don't worry. Please on your mic. Hello, is mic? This is okay. Okay, you can convey with your. So suppose you are doing some project. You are doing the UART protocol. Example, you are doing the UART protocol. So you are represent your output in 7 segment. So here the 7 segment is available in this FPGA board or not? Hello. I mean, this is not for Ajay Kumar. So all of you, please listen. You are doing some project. You are doing some UART protocol, and here you can represent with output in 7 segment. So the 7 segment is inbuilt. Suppose you can use the LCD. The LCD is available on this board. Is there any LCD? Is there any LCD on this board? Tell me, man. Is there any LCD on this board? No LCD. So what we have to do? What we have to do? So here we can use the jump. We can use this XDC. We can use this PMODs. I mean, we can use this PMOD with jumper wires. Here we can connect the LCD for external connections. For external connections. Suppose I'm doing the one project. From example project, I'm doing one project. So for my project, I want the Bluetooth sensor. Is there any Bluetooth sensor is there? Tell me, Ma, is there any Bluetooth sensor? USB is there, power cable is there. Is there any Bluetooth sensor? No. So what we have to do? We have to use this PMODs and do the external. We have to use this PMODs and do the external connection. We can connect the one Bluetooth sensor, one Bluetooth digital sensor. That's it. That is for PMOD for external connections. We don't have any inbuilt function, so we can use the PMODs. We can do the external connection. That's it. This is the meaning of PMODs. And we can use it the holes for the jumper connections, jumper wires. We can, we all know about jumper wires. You can connect the jumper wires and you can use it for it. Okay, all of you. Okay, shall I come into the next point? Is it, are you understand for the what is the meaning of PMODs? I mean the inside. I mean from that board, any another side you can show the pin numbers. Okay, don't worry. Already understood about these PMODs. What about Dattatreya Sharma, Kush Patel? Okay, coming to this another one. This 7 segment, you all of know about it. This 7 segment very well. We can represent with output with numericals. That's it. I mean numericals. And this is the clock pin. This is the clock pin. 100 MHz by W5. Okay, don't worry. I will explain it on. Okay. And this is the 7 segment display. 7 segment display. We can represent the output within numericals. Because of sir, why can we represent with numericals? Why can we not use it for the LEDs? Sir, here the LEDs is there for the output representation. Why we can connect the 7 segment? Some members have doubt. I mean, some normal members have doubt. See, ma, you are doing some project. You are using the LEDs. You are using this common LEDs and switches. You're using the binary representation of LEDs. Some outside member is come. The member is easy to see the output. He understand what is the output of the program. Some output is number, some X person, your faculty is come to see your output. Is it directly they can understand what is the output from the LEDs representation? They cannot understand. In numericals, they will some easy to understand. Okay, it is 1 to 0, 0 to 9. Okay, this is the Morton counter. Okay, this is the switches. Okay, this is the something. They can easy to understand. But the numerical representation, this is the purpose of switches. I mean, this is the push buttons, and this is the switches and LEDs. That's it. That is the purpose. And the one thing is remaining. This is the VGA. This VGA is for video graphical array. Video graphical array. I mean, we can represent the output with video. That's it. We can represent the output with video for the VGA connection. We can represent the output with our VGA connection. In this VGA, you are using some. I mean, we are of under guiding my students. They have done the many kind of gaming. They have done the many games like ping pong game, dinosaur game, and the Shinshan game is there. Shinshan game. I mean, Shinshan. They have developed the Shinshan game also. And they are doing the Doraemon game and some games of they are developing using the FPGA board. They can write the Verilog code. Only the E3 E2 students. They're doing the E3 E2 students, and if not the final year students, E3 students are doing this project. E3 students. They are not the final year and they are not the MTech. Only BTech students. E3 engineering third year. Because of with our guidance and our support. Okay. So in our trending, you have to connect. Machine should be connecting with any kind of employee from the company. It's a nowadays trending. In our own way, you can choose your own decisions. That will be, I mean, in own preparation, that will be useful for. That will be not useful in these kind of days. Your own preparation, your college preparation, your college knowledge, it is not useful for these days. Trust me. It is not useful for these days. This is not enough for these days. You have to want the external knowledge from from our companies, this kind of companies. Okay. So this is the overall connection about the FPGA board. Yeah, thank you. And so sorry, ma, I did not continue this class. I mean, because of I have to close this session. So that's it. You have any kind of doubts because of it will take the time of FPGA code dumping. Okay. So some members are did not know the Verilog code also. I know it very well. So from next time I will contact you. I mean, you have to contact me. I will give my mail ID. So I mean, the Surya will. So you have to contact the Surya, and it is very easy to you. He will arrange the next class. Okay. Yeah. So if you have any doubts, so please ask me. I mean, sorry, man, there is so much of they have. I've had a long time. I have another work, so try to understand. Okay. So if you have any doubts, so please ask me. So otherwise, we will close the session. Anyone have any doubts? Any kind of sessions, subjects, companies you have to objects? I mean, so I am referring the many students into many companies like Analog Devices, Synopsys, Intel company, Qualcomm. I'm refer the many students. So they will accept my students. I will give some training. So that's why they will accept my students. Yeah, but I have only idea about on the roadmap for the VLSA, digital VLSA, not for the analog VLSA. The analog VLSA, you can use the CMOS and something. Yeah, I will send it to my notes. Don't worry. Roadmap is very important. Okay, I will send it to my notes. If you have any time, I mean, I will explain. I mean, so try to understand one thing. I cannot explain all things in these 2 hours. You all of know about it very well. I cannot explain this all things in about VLS in 2 hours. There are nearly, yeah, is definitely the Verilog knowledge is very helpful to the DFT design. I mean, this DFT roles. There are 20 kind of not only this DFT is not only this one and only DFT. They have design verification is there, RTL engineer is there, design RTL engineer is there, design digital design engineer is there, FPGA prototyping engineer is there, emulation engineer is there, DFT engineer is there, synthesis engineer is there, physical design engineer, physical design verification engineer, testing engineer, routing and I mean floor planning and power planning engineering is there, STA engineer is there. They have many kind of 20 kind of roles in our VLSA. They have different 20 kind of works. I mean, have 20 kind of nearly 20 to 30 kind of roles in our VLSA. You will get any kind of job. You will get the salary for after 3 years. For after 3 years, you will get the 15 to 20 lakhs. That is more than software. For the software students, they will get the 3 years experience. They'll get 8 lakh, 10 lakhs only for maximum company of Google. But for our hardware engineers, so you will get the after 3 years, you will get the 3 years experience. You will get the salary of minimum 20 lakhs, 24 lakhs. That's it. Yeah, yeah. I will provide it in notes, ma. So sorry for that. Yeah. Anyway, so some members want to do roadmap for this in this group. I know it very well. So, but I will provide it in my notes. So one thing you have to understand. So I do not explain the overall things in for yeah. I mean, see, we did not give any kind of guarantee. Guarantee means this is for only for someone for 45 days. We did not give the 6 months training. That is a level 2. This summer for the level 1. Okay. See, we did not gain any key of job estimate. That's the very harmful. That is the very harmful. The students, the companies also. Because of I am also one company. This is not a kind of institute. This is not any kind. The SSIT Semiconductors is not kind of any kind of institute. If we are working in the company, we are doing some FPGA prototyping services. We are referring the candidates into AMD and Qualcomm and VConnect and the Chip Spirit and many companies there. We are giving the only the qualified students with our training. Only within our training, we will do some qualified students only. Because of you have to understand one thing, you are paying the some 3,000 or 4, I mean only the 5,000. You have the strength, yeah, definitely you will get the job. I will give my 100% sure. You have to interest, you have pay attention and interest, definitely you will get the job. Otherwise, you have any kind of cleverness, you have any kind of intelligence. You didn't. If you have no interest doing some projects or public, if you are doing some projects or preparation, you did not get the job. That's it. Yeah, minimum have many doubts of roadmaps and kind of anything. Yeah. So not only for this one, any kind of preparations, I will give some suggestions for the analog devices. But the time is too short. So I think so. Please ask me. Please ask the doubts now. I will close the class within 5 minutes. Within 5 minutes, I will close the class. So I have so much of project works is there. So try to understand. Okay. Yeah. Hello. 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 Yeah. Please, Sai. Please. Yeah. Please start. Time ఎక్కువగా లేదు. So తెలుగు. Yeah. In your resume, you have to fill it with your projects. Connected with industry topics. See here in our guidance, I'm doing the protocols and some application based projects because of it is connected with industries. It was connected with industries, and we are doing some paper publications also. Paper publications very important for the resume, and projects is important for the resume, and certification is important for the resume. Yeah, real time project. Yeah, real time projects. Why not? In our Arduino, we are doing some real time projects. In the FPGA board is suitable for the real time projects. See, Arduinos. Can I say something? Arduinos are like there is difference between the Arduinos and FPGAs, like toy car and Toyota car. Toy car ki Toyota car ko nam difference unnama between the FPGA board and Arduino. Because of Arduino code, it is not useful for that. But FPGA code, it is useful for the chip fabrication. So that way I'm saying this point for the toy car and Toyota car difference. This is the Toyota car. I will saying the example not like that. Okay. Yeah, the paper publication process. So I cannot disclose the process in openly. So if you have interest, then come to the summer internship. We are only writing the paper. I will give the full support. That's it. I will process this. I will disclose to the outer students. It is nothing. It is not possible. Yeah. Okay. Shall we close the class? Any doubts? Hello. Hello. Shall we close the class? Are you satisfied with this class? Tell me your own feedback. Don't worry. Tell me your own feedback. No. Tell me your own feedback. I don't want much of appreciations. I have a lot of appreciations from the outside students. Tell me your own feedback. That's it. That's it. Yeah. Yeah. Yeah, okay, I will left from the class. So if you have interested, then come to the summer internship. See, this is the 1% of my summer internships. That's it. This is the 1% of my summer internship. 1 or 10. This is the 1 or 2% of my summer internship. In summer internships, you have to learn the interview questions. I'm giving the training from the interview questions. Interview questions and subject, project and paper publication. In one summer internship, you'll get the all knowledge. That's it. That will be depends upon you. Okay. In one summer internship, you will get the interview questions from my side. Because of here, we are some referring some many candidates, so they will give the interview questions. They have some leakage of the interview questions to me, so I will give the practicing the interview questions to my students. So I will the interview questions, projects, publications, and the subject. In one summer internship, you will get the all knowledge. So please try to understand. So that will be depends upon you. Okay. Okay, guys. Yeah, you can contact the Surya. It is very useful to you, Ajay Kumar. Contact the Surya. Who shared this link to your mail or whatever it may be. Okay, contact that person. They will guide you for the how can we log in summer internship. Okay. Okay, guys. See you later. If anyone interested to join summer internship, so we are doing some best projects like smart stick agriculture and aquaculture. Okay. Thank you. Bye bye.